In business, growth is good, and digital transformation is driving growing businesses like yours to the cloud to stay competitive. But extending your IT infrastructure to the cloud, whether for footprint expansion, on-demand capacity, test dev environments, virtual desktops, or disaster recovery, can be challenging. Mismatched architectures, different tools, skill sets, and operating models force IT to waste time re-architecting and refactoring applications, leaving you with fragmented security and increased risks, costs, and complexity. But now you can meet these challenges head-on with VMware Cloud on AWS, a seamlessly integrated hybrid cloud solution that extends on-premises vSphere-based deployments to VMware environments running natively in the AWS cloud. With VMware Cloud on AWS, you can provision an entire software-defined data center in under 2 hours. And with VMware HCIX, migrate or extend your data center to the cloud with minimal end-user disruption. Also, you can onboard VMs easily using content library templates. Once onboarded, manage your hybrid cloud environment using familiar vCenter technologies and workflows. Leverage Hybrid Link Mode and vCenter Cloud Gateway to get a consolidated view of your hybrid environment, whether from on-premises or from the cloud. And take advantage of high availability features such as vSphere HA, automated host remediation, and stretched clusters, so your developers can focus on core business requirements, while the infrastructure takes care of availability. Achieve improved efficiency through automated resource optimization with elastic DRS and policy-driven resource management. Secure and protect your enterprise applications on-premises with vSphere Platinum, and leverage end-to-end security in VMware Cloud on AWS with features such as NSX microsegmentation, data at rest encryption delivered by vSAN encryption, and encrypted VMmotion for data in motion encryption. Finally, get world-class support at your fingertips with unified in-product support and 24-hour chat support 5 days a week. To learn more about how VMware Cloud on AWS can give you an efficient and secure path to the hybrid cloud, visit cloud.vmware.com today.
My name is Iheb Marzougui. I am a Senior Solution Engineer with VMware Mitna. Welcome to Tech Talk Live event series. VMware decided to start these webinars to address the current circumstances and help you learn the best practices to achieve success in your business continuity experience. Today, I'll be talking to you about VMware Cloud on AWS, technical deep dive, and then we'll be hosting a live question and answer session. Should you wish to get in touch with us after the session, please click on the Contact Us form. So, I'm based in Tunisia and my role is to work with customers and help them understand an adult VMware Cloud service. Before we get into that, we are going to basically set a framework for everybody, really to know and to be on the same page as we go through this. Everybody understand that we are headed to a multi-cloud world. When speaking to our customer, they have a very clear cloud strategy in mind, and the preferred approach actually is a hybrid cloud. Unlike before, when we had a binary decision to make whether or not our cloud would go either on-premise or to the cloud, public cloud. We now have the ability for our customer to choose both. So that being said, a lot of our customers talk to us, and a lot of the issue that they run into when building different clouds or expanding to the cloud begin with the operational consistency. So generally, by running workloads on premise and then running those same workloads in the cloud, there are operational consistency that occur because of the difference between platform and so. What do we mean by that? Different cloud environments require a different skill set in management, backup, monitoring, tools, and so on. Customer would have to consider different control and security methods. So in a lot of cases, there will be the need to change internal operating process and maybe even change team structure. Most of traditional enterprise applications are typically stateful applications, run on resiliency based on infrastructure that is leveraged by things like VMware HA, DRS, and more. However, in the public cloud, you get very different experience. So it's different set of SLA. You must rebuild or refactor your application to become stateless or to incorporate resiliency within in the application itself. And so this could be very long and very expensive process. We have some compatibility issues between private and public cloud. So those could be issues with privacy and data sovereignty also. Issues with latency or application which are latency sensitive, for example. And so all these challenges make it very difficult for customer to basically adopt that multi-cloud strategy. The question now is how we address this with VMware. Well, we give you the best of both worlds. It's the same look and feel as your own data center, with the flexibility of the public cloud and the ability to take advantage of Amazon native services. So there is no need to refactor or rebuild application in order to bring them to public cloud. And so we are able to do this by having two powerhouses coming together. So let's have a closer look on. So on the left hand side, you can see your on-premise data center. Alright, this is your on-premise environment where you are in charge of everything from the power, the cooling, and the way down into the applications. On the right hand side, if we stretch this, you can see the AWS services. Now, if you have been working with AWS, this is where your workloads will be residing, right in the middle. You will find VMware Cloud on AWS. As we said, this is a jointly engineered solution between VMware and Amazon, and it brings VMware enterprise class software-defined data center, of course, or what we call SDTC to public cloud. It's a combination of vSphere, vSAN, and HCIX, along with a dedicated vCenter server. So it's all deployed on a bare metal EC2 Amazon infrastructure like any other vSAN ready node. There is no nested virtualization going on, no dependency on Amazon machine image. So we package this up and deliver it all as a service. So it's also sold, delivered, and supported by VMware. If you look in this on that gray ribbon here around the two vCenters instances, this is effectively a feature called hybrid linked mode. We'll talk about it later. And the last piece of the puzzle, and the one I think is very important to our customer and absolutely a key differentiator for the VMC on AWS, is the integration with Amazon native services. So we have this unique speed, low latency connection between our VMware Cloud SDTC and Amazon native services through something called ENI. You can think about that as a dedicated network connection from our VMC environment into a native AWS environment. It gives our customer direct access to native cloud services and allow them to leverage some very interesting architecture. So get in touch with our team and you will see how you can do with this hybrid cloud. So by partnering with AWS, we are able to leverage the growing global footprint. So essentially, anywhere that Amazon has a region, we plan to be there. So last slide, before we go into more of the technical stuff, is, you know, there is really three big use cases that we see over and over again with our customer. So the first one being when your customer are looking to maintain and expand the data center footprint. And so this is may be because they are looking to add additional geographical location, so they need to expand. In addition, an additional geolocation, they are looking out to onboard recent merchants or and acquisitions maybe, or they just simply running out of space or resource on premises. We have customers who are looking to modernize and or consolidate from multiple data center location, or maybe there is a need to migrate specific workloads and application to the cloud in order to take advantage of native cloud platform services in order to bring innovation and derive business value of core application. Disaster recovery is probably also worth mentioning here, because we do have customers looking into VMware Cloud for new data center location, or may somewhere to complement their existing PR strategy, as our famous SRM is included as a service in VMware, maybe you know it, or maybe there is just need for burst capacity for seasonal workloads, or maybe testing dev environment, and now of course with Tanzu is out, I think we will have a lot of customers using this for DevOps initiative, as Tanzu will be guarantee to our customers a modern software supply chain based in your favorite DevOps tools and frameworks to build and deploy microservices. I think really we need a dedicated session to Tanzu on VMware Cloud. So now we have covered all this. Let's have a look at the cloud software defined data center inside. So basically, when you spin up an SDTC, what do you get? And so what we give you here is a very scalable service, a very scalable environment. Each software defined data center can have up to 20 vSphere clusters, all managed by the same vCenter. Each cluster can scale up to 16 hosts, which gives us 120 vSphere per vCenter. All of this will reside with you within your own VMware account. So if you need to add more, you can have up to 10 of this SDTC within that same account, or the same logical grouping that we call an organization. As I mentioned earlier, the environment is managed and supported by VMware. So we take care of managing, upgrading, patching all the hosts and all the management component of your SDTC. To ensure that all environments behave correctly, VMware manages the system exclusively. So there are some restrictions compared to on-premise SDTC, like no direct access to management VM, which would be things like your vCenter server, NSX manager, and so on. Please be aware that only this first flow for services contain the management part. Every additional vSphere is fully available for customers' workload. So by not having to deal with this basic operation, you can focus on what really matters. And when it comes to capacity management, I think you are probably familiar with DRS. DRS has been around for a long time and it's a great feature, but I think in cloud world DRS has limits, right? In the end, you only have so much hardware available to the DRS cluster, and when you feel that capacity, at some point you are just going to round out and you just can't go any further. What do you do next? Well, traditionally on-premise, what you would do is you would go and rack and stack another server and add a server to the network, and some manual processes would ensure all is okay. However, because we are sitting on top of AWS infrastructure, we have a lot more options here. We can actually dynamically add capacity and then use elastic DRS to then manage that capacity as part of our cluster. So in effect, what happens is elastic DNS has the ability to grow or shrink the cluster depending on how much capacity you are using, what options you have chosen. This is a really exciting feature, and I think we have just started to scratch the surface on this one, because with the announcement of vSphere 7 and the new DRS algorithm, I think things gonna change quickly. So VMware Cloud on AWS has a couple of host options right now. As I said, we started with bare metal hosts from Amazon i3 family, and each of this has two Intel 18 cores per socket, giving us about 36 cores and half terabyte of memory each host. Of your 3-node, of course, as you may know, we start with 3-node in VMware Cloud on AWS, and has about 8 NVMe, giving us about 10 terabytes overall capacity per host. Customer can choose to configure their own storage policies to provide the appropriate level of security, and depending on the customer number of hosts in the cluster, the arrays coding could be 1, 5, or 6. Be aware that by default, vSAN encryption, deduplication, and compression are enabled and cannot be turned off. We recently made available a new instance from Amazon F5 family. And so this is a little bit different than the i3 hosts, because they are effectively diskless hosts, and in terms of compute they offer a slightly high compute resource. So R5 deliver a total of 48 core per host and 768 GB of RAM. And don't forget that we need at least 3 hosts to start our journey. R5 takes advantage of Amazon Elastic Block Storage. So specifically, R5 uses the Amazon General Purpose Activities or GPT volumes, and split this into 3 disks groups, so each host can be configured with 15 to 35 terabyte of storage. So these instances are great for capacity optimized workloads and potentially deliver fast host remediation time in case of host failure, because again we are using EBS volumes instead of internal drives, and so you can attach and detach those volumes quicker. So what is host remediation or self-healing automation? First of all our hosts are filled with redundant components, but failure may occur, and as we said, this is delivered as a service. So we look after the environment, and once again we take advantage of AWS feature called automated host remediation or VMC feature. That means that if we detect an issue with a host or a host failure, we'll go ahead and add an additional host to the cluster, configure it, and start the process of rebuilding or migrating data. As I said earlier, vSAN encryption is enabled by default, and it is on each cluster that's deployed in your SDTC and can't be turned off. This is an important feature, so something that we made available for our customer. While on-premises, vSAN can be used with any compliant key management service. With VMC on AWS, we utilize the Amazon KMS service only. Another cool feature, certain mission-critical applications are licensed per core. So we have introduced the ability to turn off CPU cores within a VMC cluster, and customers will have the option to specify the number of cores proposed across the entire cluster, and thus reduce the cost of running some of those mission-critical workloads. For those same very critical workloads, we have the capability to use a stretch cluster feature on VMC. By default, the SDTC is deployed on one AWS availability zone. With the stretched cluster feature, we can deploy an SDDS which spans two availability zones. So this basically distributes your workload and hosts across a different AZ. A witness is made available in a third AZ. Most of AWS regions have 3 availability zones. Some of them have more even. And again, it like any other cloud service would always recommend you that please check availability of the services or products within the desired region. So basically, we will automatically expand workloads and logical networks, and we'll use vSAN, stretched cluster feature, between the two AZ, and in the unlikely event of an unavailability zone or unavailability zone failure, vSphere HA will attempt to restart workloads on the surviving site, and therefore giving customer the high availability and zero RPU for their critical application. Just to know, all the networking in VMware Cloud on AWS is provided by HCIX, and so we previously saw that from compute perspective we have 2 different portions: the SDTC, the management of the workload part, and the production or workload part. So very similarly, in order to provide connectivity to the VMC, you need to know that there is the management edge gateway that allows the customer to connect management components of the SDTC, like vCenter, for example, and we have the compute gateway, which is also an NSX edge that allows for ingress and egress VM network traffic in the workload part. And you can control or modify access and firewall policies for your workloads here. So let's dig a little bit in a network configuration. So we try to make it a very, very simple and easy process for customer to administer and perform those sorts of day-to-day operation. So if we look at features that NSX provides, like connectivity or IPsec VPN, or direct connect, which is a high bandwidth, low latency direct connection to AWS regions, which is provided by Amazon. Or there are security features like firewalling and microsegmentation, which is basically a feature of NSX that allows you to have more granular control over east-west traffic between workloads. So all of this and more are available within few AWS features like VPC or other. Over here, the VMC console, and this is where we are going to set up your VPN connection, create network or segment, as we will call them. So as you can see here, we are going to allow a couple of different ways of doing that. And what we see here is either adding a point-to-point VPN or direct connect option, and those are probably going to be the 2 most common ways. So let's start with direct connect, and for those who aren't familiar with this, basically a direct connect is a low latency, high bandwidth connection directly into AWS infrastructure. It's ideal for customers that want to be able to do VMmotions from on-premise to the VMC. For those who don't have direct connect and just want connectivity back to their on-premise environment, you will need only what you will need is a VPN that allows you to do IPsec. So that may be a software VPN, that may be a hardware VPN. It really doesn't matter as long as you can meet the IPsec requirement. Once you have the VPN tunnel up You can do things like allow workloads from on-premise to talk with workload running in the cloud. You will be able to do things like hybrid link mode, where you are able to take a look and manage both environments from one specific vSphere client. So basically the VPN tunnel makes things really nice and easy for you to manage multiple sites without having to have multiple tabs. Just before I forget, please, you can use NSX standalone for free to have this IPsec VPN as a software option. So we have talked a little bit in depth about storage and networking, compute of the host, but what do you do once you deploy an SDTC, once you have the connectivity set? I think what's next will be how do I get my workloads into my VMware Cloud on AWS environment. There are a couple of options here. The first one being very simple, which is effectively sharing content using the content library. This is a good way to share OVAs, templates, maybe ISO image and so on between your on-premise environment and the VMC. We briefly mentioned hybrid links modes at the beginning of this session. This is probably one of the most compelling reasons why customers are excited about VMware Cloud on AWS, is the fact that you can have vCenter all within a single pane of glass. Now, in the past, you have been able to do that in an on-premise environment as long as your vCenter server are part of the same SSO domain. The problem here is when you go to another cloud, for example, VMware Cloud on AWS, you don't have a way to specify the SSO domain. For VMware Cloud on AWS, what we've done is we have gone ahead and we have created what's called the hybrid linked mode as well as Cloud Gateway. They both accomplish the same things here that allows us to actually merge SSO domains and see both environments within the same vSphere client. This allows us to do things like code migration and VMmotion directly from the same UI, and of course note please that there will be some prerequisites here of bandwidth as requirements and so on. Now, what if we need to migrate a large environment, thousands of VMs? Another option that we have is called HCIX. Now HCIX is an appliance that you would install on premise and is by default is a cloud service in VMC that allows you to do not only things like VMmotion and code migration, but it allows you to do everything in bulk. We have seen customers moving hundreds and hundreds of workloads with zero downtime using HCIX. One of the cool feature with HCIX is the fact that unlike a granular VMmotion that requires 250 megabytes per second, HCIX only requires 100 megabytes per second. We also have things such compression, LAN optimization, and we can stretch our layer 2 networks directly using HCIX. There is also replicated assisted VMmotion, which is the ability to go ahead and replicate as many virtual machines as you want to a target site, but instead of powering them off and then powering them back on in the target location, we leverage the functionality of VMmotion to just flip those few bits and keep your workload running without any downtime. With HCIX, we can migrate everything, even between different versions of vSphere. And lately, last year, we made available OS assisted migration using this HCIX. Obviously, it will give you the ability to provide a bulk migration of guest non-vSphere virtual machine to VMware vSphere on-premise or on cloud VMC, of course. Now, we've only got a few minutes left, so customer usually ask about account structure. and data charges. So here is a quick overview of what these charges look like. As with any other public cloud, data going into the cloud is free of charge, and the egress is chargeable. So depending data traffic going over the ANI from VMC to the connected Amazon VPC in the same availability zone is free of charge, of course. So this gives you the option to access AWS native service residing in there without having to worry about data traffic shares. And so on, and so basically here anything in blue on this slide is paid by VMware and charged back to the customer, and anything in green is paid by the customer directly to AWS. So how can I get started? A great way to start is to try a hands-on lab, and I added a few useful links here to frequently asked questions, pricing, sizing, and so on. Another interesting thing that we do that's a little bit different for VMC is that our roadmap is publicly available, so you can go online and have a look at what we are working on and what will be the next cool feature that we are looking to bring out to our customer. Finally, hope you all enjoyed and learned from this webinar, and I just want to remind you a couple of things. Please, if you wish to join us for the live question and answer session, please join our Facebook group now. If you are watching this webinar from platforms other than Facebook, then you can hit the link in the bio to watch our question and answer session, where I will be responding to your questions live. And remember, should you wish to get in touch and get more information, please click on the link, contact us below. Thank you and stay safe.